Hey guys, Mr. Middleton here. Today we're going to talk about simplifying radicals with variables. Okay, we'll be able to simplify radicals that contain variables, and we'll be able to simplify radicals containing a combination of numbers and variables. Recall from last lesson that when simplifying radicals, we looked for pairs of numbers underneath the radical. Okay, we're going to do the same thing today, except now we're going to be using variables. Okay, so let's simplify this. We'll start simple and go on from there. So we're going to simplify this. We have radical a squared. Remember that we could rewrite this as a times a, and then we had a pair of a's, right? And so when we have our pair, we can take it out from underneath the radical, and radical a squared is a. Okay, remember that a radical is the opposite of a squared. Okay, so they essentially cancel each other out. Okay, we'll do the same thing here. We have a to the fourth, so we have a times a times a times a. So here are our pairs. Okay, we have two pairs here. We could write these out, and this time we have a times a out here. Remember, a times a will give us a squared. Okay, as these numbers increase, a to the sixth, see that we probably need a better way to do this than to just write out all the variables that we have, just so that we can solve this, in the cases that it gets big. But we have three pairs of a, and we have a to the sixth, a times a times a, and that'll give us a cubed. Okay, now I have a to the hundredth, which really makes us think, okay, we have to find a shortcut. Can't write a 100 times. It's not going to be worth it. So let's look back at the last three problems that we did and see what's happening. Okay, notice the exponents here from the beginning of our problem to the end. Square root of a squared was just a. Let's say to the first for this example. Square root of a to the fourth was a squared, 4 and 2. Square root of a to the sixth was a to the third. Okay, so notice what's happening to our exponents. Okay, when we take the square root, what's happening? Well, they're being divided by 2. So square root of a to the 100th power, I can find that answer by saying how many pairs will I get in 100? Well, 100 divided by 2 gives us 50. It means there are 50 pairs. So without having to write all this out and show that, I just can divide by 2 and say, okay, square root of a to the 100th will be a to the 50. Okay, so all exponents inside the radical, in this case, were even. Okay, and the exponents in the simplified version are half of the exponents inside the radical. All right, what happens when you have an odd exponent? Again, we can look at this and write these out. A times a times a. Take my pair. And I have a pair, so I take that to the outside. Then I have an a without a pair, and so it remains inside. Okay, we can do the same thing here. A times a times a times a times a. There's 5. So again, now I have two pairs. So a times a on the outside and 1 without a pair. Okay, because these two numbers are on the outside, I'm going to simplify by multiplying those together. Give me a squared. And then the a on the inside has nothing to simplify with it, so it'll just be radical a. Now again, I'm not going to write a 35 times. I need to find out kind of a pattern here. And I'm going to use this with it. Well, we know we can divide by 2, and that should give us how many pairs there are. But in this case, when we divide 35 by 2, well, that doesn't give us a whole number. It's not really pretty like before. But this is when we'll use remainders. Okay, 35 divided by 2 will give us 17, and we could say 0.5, but if you remember from second grade, we used to say like remainder 1. Okay, and that's where this is going to help us out, because we know we have 17 pairs of a's, 8 to the 17th power, and that one remainder will remain inside. Okay, so all of the simplified versions have one variable left over underneath the radical, and the exponent on the simplified version is half of the even number right below the exponent. Okay, so 35, since that's I, we say, okay, half of 34, okay, which is 17 with one left over. Okay, and this is basically all you need to know for simplifying radicals with variables. These ideas will be combined with the ideas from last lesson, as well as ideas from next lesson. So let's practice this on the back. Alright, so here we go. Starting off, we have m to the 6th, n to the 9th, p to the 3rd. Alright, so I have m to the 6th. How many pairs of m's do I have? I have 3. Okay, so I'm going to divide that by 2. I get to write that on the outside. I have m. Actually, this is what I'll do first. Okay, that's how I'd approach it as we get a little bit more seasoned. But I'm going to start off by saying, usually I like to separate this out just at the beginning so I can see, okay, I can deal with m, n, and p separately. Okay, it kind of makes it a little bit easier for me. Okay, so m to the 6th. How many pairs of m's do I have? Well, I have 3 pairs. N to the 9th. Okay, well now I see that, hey, this is an odd number. So I'll do 8 divided by 2, 4, and I know I have 1 left over. P to the 3rd. So I have P divided by 2, or sorry, 3 divided by 2, 1, with 1 left over. And now what I'm going to do is I'm going to take all the numbers to the outside, I'm going to multiply them together. M cubed, n to the 4th, P. And then the numbers that were left underneath the radical, I'm going to multiply together. N, P. And that's my answer. Okay, so we can do that with mixed variables. We can also kind of do that approach when we have numbers mixed with variables. Okay, so if this helps you out, if you're like, oh, numbers and variables, we'll separate them. Okay, remember radical 27 x to the 8th is the same as radical 27 times radical x to the 8th. Okay, and so we'll simplify radicals 27, just like we did yesterday. Find 2 numbers to multiply to give us 27. Okay, take the pairs outside, leave what's not paired inside. Okay, we have x to the 4th now. Our x to the 8th we'll divide by 2, that gives us x to the 4th. Okay, and that's outside. And now again, outside times outside, so 3 is outside, x to the 4th is outside, then radical 3. Alright, you look at number 3 and you see, hey, we already have numbers to the outside. How does that affect our problem? Well, just like before in these other 2 problems, what we have outside multiplies by whatever comes outside. Okay, so what I'm going to do is I'm going to just kind of separate this out here a little bit. Okay, and now I have radical a to the 5th, radical b squared. Okay, just rewriting that problem as we work to simplify. Okay, so a to the 5th, that's an odd number, so I'll do a to the 4th. 4 divided by 2 is a squared with that leftover a. Okay, b squared, I can divide that by 2, that gives me b. Okay, a squared, b is already out here. Okay, and so now I multiply all the numbers outside together, so a squared gives me a to the 4th. B times b gives me b squared. Radical a is inside, nothing else to multiply that by, so there is my answer. Alright, number 4. 3x squared on the outside. We've got that left inside, so we have 54. Radical x to the 7th. Do this one for me. Okay, bring that one to class finished. Alright, let's look at number 5. Now there are a couple different ways that you can handle problems like number 5, because I'm asking you to multiply and simplify. And so here's how I'd probably approach this problem. I usually like to multiply all the stuff together because I like to have a big number. Okay. Actually, let's just group these together. We have the radical 10 and radical 5. Radical 10 times radical 5. Okay, kind of taking 2 steps at one time. We've got the g's we'll put together. So radical g cubed times radical g. We have the h's that we'll put together. So radical h to the 4th radical h to the fifth radical. Okay. Alright, so when we multiply all this together, we have radical 50. We have radical g to the fourth. G to the third. We have radical h to the ninth. Okay, and so now it looks just like the problems that we were doing before. Simplify each of these radicals separately. 25 times 2, 5, 5. So we have 5 radical 2 for radical 50. We have g squared, because g to the fourth divided by 2. We have h to the fourth, and then a leftover. And so now we're going to do all the outside numbers multiplied together. 5g squared h to the fourth. And then the numbers inside the radical that are left, we're going to multiply together. And so that'll be our final answer. Okay, let's get some ways on number 6. So number 6, look, we have some numbers on the outside. I'm going to multiply those together. 8, or negative 8, z to the fourth. Then inside of our radical, we'll kind of separate these in the same step. We've got radical 21 and radical 3. We got radical z and radical z to the 10th. Okay? Finish this problem for me. Okay? Follow this process, finish that problem for me in number 5. Okay? So there we have it. We've done some problems. We showed some kind of shortcuts of the law for simplifying radicals with variables in it. We've done some practice problems where variables and numbers were both present. And we'll work some more with radicals and simplifying them tomorrow. See ya.